Well, good morning, student, or I guess good afternoon, or this case may be. This is going to be Unit 2, lesson number 9. And so we're going to be talking about which variable to solve for, and this is part 2. And so, they'll call it lesson 9, part 2. There's no lesson 9, part 1. This is lesson 8 was which variable to solve for, part 1. So it's a little bit confusing the way they numbered this stuff. So, but we'll go through this thing. And so they start out with, they have this little octahedron, icosahedron here. An octahedron, then they go to an icosahedron. So in an earlier lesson we had this equation. The vertices plus the number of faces minus 2 equals the number of edges. And so they start out here. It says write an equation that makes it easier to find the number of vertices in each of the Platonic solids as described. Okay. So again, we're trying to solve for vertices in these things. We're going to try to solve for V right here. Okay. And so we're going to start out with. It starts out with an octahedron shown here. Has a face. Has 8 faces. And then an icosahedron, which has 30 edges. So we're just going to go and restate these things to solve for V, or the vertices of this. All right. And so let's go back to our overhead camera. All right. So this is the equation that we have here: V plus F minus 2 equals E. All right. So we're going to start out by substituting in 8 for the F. All right. So when we get that, we got V plus 8 minus 2 equals E. And as you can see, we have like terms right here between the 8 and the 2, so we can kind of combine those. So V plus 6 equals E. But again, we're always trying to solve for the V. We want to start off with the vertices here. So to solve for V, that means we got to move this 6 over to the other side. So we just subtract 6 from both sides, and you get V equals E minus 6, or vertices equals edges minus 6 on that first example where you have 8. Okay, so I'll just pan down here. So this is what our answer gets to be. All right, and then the second one says the icosahedron has 30 edges. So again, we're going to start with this equation, only they're going to substitute E in right here. So V plus F minus 2 equals 30. All right, and now again, we're going to try to solve for V, the vertices. So that means I got to get the F, move that over, the 2, move that over. So I'm going to subtract F from each side, and I'm going to add 2 to each side, and they'll disappear on this side. So the vertices equals 30 plus 2 will be 32 minus the F. And so now you've solved for the vertices on that one. Okay, and so that's where we got our little answer right there. All right. Moving on for number 2. This is a Buckminster fullerene, also called a buckyball, is a polyhedron, meaning many-sided figure, with 80 vertices. It's not a Platonic solid, but the number of faces, edges, and vertices related the same way those of a Platonic solid. Write an equation makes it easier to find the number of faces. So we want to find the number of faces on the buckyball, as we know how many edges it has. Again, it has 60 vertices. All right. If it has 60 vertices, we basically need to go and figure out this little part right here. Okay, so we can still use our regular old equation there. Okay, and so if you look at this, the V plus F minus 2 equals E. And this particular one, we know that vertices are going to be 60, right? And so that's what we've got right here. And so we just still keep up and set up this thing, and there's our E. And so we're going to try to do is solve for the number of faces here, solve for F. All right, so 60 plus F minus 2 equals E. Solving for F. All right, so 60 minus 2, that's the same as a 58 plus F equals E. Remember, you're trying to solve for the F in this thing. So you simply subtract 58 from each side. And faces equals E minus 58 for this one particular example. And so that's where we get our numbers there. Now, of course, you can take this equation right here, this one solves for E, so the number of edges. So if you're given the faces, you can figure out the number of edges. For this one, if you're given the number of edges, you can find the number of faces. So they're related equations, equivalent fractions. All right. On to 9.2. An automobile manufacturer is preparing a shipment of cars and trucks for a cargo ship that can carry 21,600 tons. The cars weigh 3.6 tons each. The trucks weigh 7.5 tons each. Write an equation that represents the weight constraint of the shipment. Let C be the number of cars and T be the number of trucks. So I'm going to go kind of expand that out just a little bit. So what they're talking about here is you have 3.6 tons per, let's see, for a car. And we need to know the number of cars. And so they like the letter, let's see, C for cars. So C, cars. And I'm going to add to that 7.5 tons per truck. And I'm going to multiply that times T trucks. And as you can see, the units will cancel, giving us just tons. And I know that the total is 21,600 tons. That's the most I can put on that ship. Okay, so we can just rephrase this as 3.6 times C plus 7.5 times T. And that'll equal 21,600, and that will be able to allow you to go and get a combination of cars and trucks, though you can match that number exactly without exceeding it. Okay, so there's your answer right down there too. All right, we just simply restated it. All right, it continues on the top of the page on page 206. It says, for one shipment, trucks are loaded first and cars are loaded afterwards. Even though trucks are bulkier than cars, the shipment can consist of all trucks as long as it is within weight limit. Find the number of cars that can be shipped if the cargo already has this many trucks. So what they're trying to do there is they're saying that you know the number of trucks already, so they're saying that T is 480, all right? And so they want you to find what C is. All right. Well, we take our equation that we just worked with, 3.6C plus 7.5, and there's supposed to be a T here, but I already know what T is. It's 480, and then altogether that has to be 21,600. Okay. And so I need to go and take this number here, and I need to solve for C. All right. Well, let's just do a little bit of math here. 7.5 times 480. 7.5 times 480 is 3,600. All right, so I'm just going to go and do this equals 3,600. All right, so I've got 3.6C plus 3,600 equals 21,600. Again, I'm trying to solve for C, so I have to go and first get rid of the stuff I can get rid of with addition and subtraction. So subtract 3,600 off of each side. And you can kind of do the math here in your head. 0, 0, 6 minus 6 is 0. 21 minus 3 is 18, so you just have 18,000. These cancel. And the only thing you have left on this is 3.6C. Right? Now that we got everything we can get rid of with addition subtraction, I can get rid of it with multiplication division, and this time I'm going to choose division. Since 3.6 being multiplied by C, I'm going to divide by 3.6. Okay, and so C will equal, again it cancels over here. Do this little math on your calculators and you should get 5,000. So 5,000 cars. That's how much you can get. So 480 trucks combined with 5,000 cars will fit into that ship. The next one says 1,500 trucks. All right. So now we can go through this each time, or we can just take this equation and we can just solve for the unknown and then do our substitution. That might be another easier, quicker way for you. So we're going to take that equation that we have right here, and let's just do a real quick solving for cars, for the C here. So I can subtract 7.5t from each side. Alright, cancel, cancel. And I can divide everything by 3.6, just like I did before. So I can just look up this equation. Since I have a whole bunch that I'm going to be solving for, one right after the other, I can just put these numbers together like this. Now I have a nice equation. I don't have to do much. I just manipulate the equation. Now I do my substitution. Right. So if we do that, C equals 21,600 minus 7.5t divided by 3.6. Now the next one says they have 1,500 trucks. So 21,600 minus 7.5 times 1,500 divided by 3.6. Of course, that's C. This time C equals 2,875 cars. Right. What happens if we have 2,736? C equals 21,600 minus 7.5 times, that's a goofy number, 2736. 2736 divided by 3.6. Again, make sure that you know how to do this math. Make sure you know how to run your calculator to do this. So your equation should look like that. And this time, when you do the math, you should get 300 cars this time. So again, as the number of trucks increases, the number of cars has to decrease. And of course, now they're talking about T trucks. We kind of solved for that first one. That's kind of like the answer for D right there. That's how you solve this thing. So I prefer to take an equation, solve for the unknown, and then move it to do the substitutions if I need to. So they kind of do things out of order for my taste. And moving on. Okay, for a different shipment, let's see if I can move this a little bit for you. There you go. There we go. For a different shipment, the cars are loaded first, and then the trucks. All right. So now, rather than starting to solve for the cars, I'm going to start solving for the trucks. So let's go and take it back and take our base equation again, which was 3.6 C plus 7.5t equals 21,600. All right. So now, rather than solving for C, I'm going to solve for t. All right, first thing you do is you got to get rid of what you can with addition subtraction. So I'm going to subtract 3.6c from each side. Cancel, cancel. And then I got this 7.5t equals this. So I'm just going to go, and since this is being multiplied together, I'm just going to divide by 7.5. There, and there's my equation. T equals 21,600. Minus 3.6t, 3.6c, my bad there, sorry, fix that, and 7.5 down below. Alright, so now they come through and they're saying, alright, how do I want to do this? It says write an equation to enter the calculator. Well, there it is right there. Boop, we just solve for it. Alright, and it's sitting right there. And then use your equation and calculator to compute, to find the number of cars that will be shipped by cargo if it already has 1,000 cars. So if it has 1,000 cars, what if the car is 4,250 cars? Well, when you do the math, when you do the substitution in this thing, for 1,000 cars, you should get 2,400 trucks. And for 4,250 cars, you should get 840 trucks to go along with that. So that's one way to do it. All right. But remember, there's your equation to use on that second part. And I'll let you go through with your calculators. It's more of an exercise in using your calculators than anything. All right. It says down here, are you ready for more? For yet another shipment, a manufacturer is shipping motorcycles which weigh 0.3 tons each. So that's about 600 pounds, which makes sense. Write an equation where you could enter in a calculator or a spreadsheet tool to find out the number of motorcycles that can be shipped M if the number of cars and trucks are known. Okay, it's kind of that same idea. So we have motorcycles, so motorcycle weight plus car weight plus the truck weight, and that has to equal 21,600 tons. Well, the motorcycle weight, you're going to need to know that it's 0.3 tons per motorcycle, which means you're going to have to multiply it by the number of motorcycles. And the cars are 3.6 tons times the number of cars plus 7.5 tons times the number of trucks equals 21,600. Alright, so that's the basic how you do this. You still have the same idea. It's tons per motorcycle times motorcycles, tons per car times cars, tons per truck times the number of trucks. And this will give you your total. So that's kind of what we're going through on right here. Use your equation to find the number of motorcycles that can be shipped by cargo already containing 1,200 trucks. So that is 1,200. And 3,000 cars. 3,000. Alright. So what you can do on that one is you can just do a little bit of math here. So 0.3 m plus, well, 3.6 times 3,000, we need to do a little bit of math there. And 7.5 times 1,200, you got to do a little bit of math there. So let's go, and I'm going to pause this here and let you see if you can do that in your calculators. And so when you look at this, you do the math, this is what you should be getting. Alright. Now obviously we have to go and solve for how many of these motorcycles I can put on. Now when you add a 10,000 and 9,000, you're getting to be like 19,000, which is really close to 21,000. So there's not going to be a lot of room for those motorcycles at this point. Alright. So how are we going to do this? Well, 0.3 m. Now if we add these two, right, you should get 19,800 equals 21,600. Right? You should get something like that when you add these two numbers together. Right? I'm going to subtract 19,800 from both sides. Cancel, cancel. 0.3 m will equal, well, if you do the subtraction here, you should get 1,800 pounds. So 0 and 0, 8 and 8, 16, carry the 1. 1 plus 1 plus 9 is 11, carry the 1. Yep, it adds backwards. Now I got to solve for m. Well, how do I do that? Divide both sides by the coefficient of the unknown. The coefficient of the unknown. Cancel, cancel. M equals 1,800 divided by 0.3. Let's just do a little bit of math here. 1,800 divided by 0.3. 6,000 of them? 6,000 motorcycles. Now think of this. You're only having 1,200 trucks. You're having 3,000 cars. And you're talking 6,000 motorcycles. So that is going to make that thing pretty full. Okay? Alright. And we're back. We're at 9.3 now. Streets and staffing. The Department of Streets of a city has a budget of $1,962,800 for resurfacing roads and hiring additional workers this year. The cost of resurfacing a 2-mile lane is estimated at $84,000. The average starting salary for a worker in the department is $36,000 a year. Write an equation that represents the relationship between the miles of 2-lane roads the department should resurface, M, and the number of new workers you could hire. Alright? So let's look at this. I got the answer here. Let's break that down. I like a little bit more breakdown than what they've got there. And so if we start this out, alright, so they're saying that it's $84,000 per 2 miles, right? the cost of resurfacing a mile of a two-lane road, right? So let's do a little bit of a correction there. So the cost of resurfacing a mile for a two-lane road is estimated at $84,000. All right, so that's dollars per miles. So we have to multiply that by M, or the number of miles that we're going to work with. All right, that's just for the stuff. And the average starting salary for a worker on the department is $36,000 a year. All right, so with that we also have to put in $36,000 per person, and then we have to multiply that by the number of people that we employ on this. With that's going to give us a total of what we were initially given up here. 1,962,800. All right. So you can do a lot of miles and not hire a lot of people, or very few miles and hire a lot of people. So you got a choice there. Okay. So that's where they come up with this equation right here. Let's say, so for M for miles. Okay. Take the equation you wrote for the first equation and solve for P. All right. So we're going to take this thing, 84,000 M plus 36,000 P equals 1,962,800. They want me to solve for P. All right. So what I need to do is I need to get this thing isolated using addition and subtraction first. So I'll subtract 84,000 M from both sides. Cancel, cancel. And then I'm going to have to divide by 3,600. Or excuse me, 36,000. So what do I got? Well, I got P equals 1,962,800 minus the 84,000 M times the number of miles I'll have to work with, divided by 36,000. Okay, so that kind of sets this thing up. You can figure out how many people you can have if you know the number of miles. All right. Solve for P. Explain the solution means this solution. The more miles you do, the less people you can hire. The more people you hire, the less miles you can do. It's a balance. All right. Solve for M. So we want to take the same equation now. We want to take it and solve it for M. All right. So we're going to solve for M. Let's start with 84. Let's put a little asterisk right there. Come back to that. 84,000 M plus 36,000 P equals 1,962,800. I want to solve for M this time. Right? So first thing I have to isolate using addition and subtraction. That means I got to subtract 36,000 P from both sides. Cancel, cancel. And then I got just this, so I'm going to divide by 84,000. So what do I got? Now I've got M equals 1,962,800 minus 36,000 P divided by 84,000. And we'll put a little asterisk right there. And that's what we've got now for a solution here. Okay. And it continues on. The city is planning on hiring 6 new workers to use its entire budget. Which equation would be used to find out how many miles of 2 lanes could be resurfaced? Well, you're solving for miles. All right, this is the one that you solve for. If you're being given the number of people and you want to solve for miles, obviously you want to use this second one. All right, and so they have this thing set up right here. We have our equation set up, and they put in a 6 for the number of people. All right, and so that's how you would find that number. And when you actually go through that, you find out that you would be able to do about 20, just shy of 21 miles of road that you could go and do with that budget and with 6 people. All right. So let's do the summary here. The summary is pretty quick. The big thing to gather out of this is that when you're given this, you have 2 different things which are controlling a total amount. Okay, it could be cars and trucks. It could be workers and miles. Okay, you're always going to have, a lot of times you'll have two different variables. Okay, so you can take these things and you can solve for one of the variables, or you can solve for the other variables, but you'll see how these are kind of, they look very similar. You still start out with 3,000. Here you're subtracting 150y, which is over here. Here you're subtracting 60x, which is over here. And you're dividing by the other guy, right? 60, 60, 150, 150. So you can see these things are very similar. And the way we solve for them is very similar. Right? So that's the idea here. And what you'll find out is that if this thing is fixed, as one goes up, the other has to go down. If one goes down, then the other has to go up. Right? It gets kind of like a little kind of a seesaw balance. They can't both go up, they can't both go down. One has to come up and the other has to go down, so they're each at the other's expense. All right. Well, that's all I have for this one. We'll continue on with the Lesson 9 practice problems next. Thank you.